Let's now have a look at multi-threading models. There are two ways in which you can get your application or your process to run in a multi-threaded fashion. You can go for user threads. So you can manage threads completely at the user level. Okay, there are libraries for that. Of course, you don't have to do everything yourself. But if you think about it for a moment, what I'm trying to say here is that in principle, you could write your code so that instead of just running the next instruction of a certain function, you have some meta code, meta instructions that periodically check, let's say, which function to run, and then select one appropriately. Okay, so you can manage threads at the user level. You don't have to do everything yourself. You can do it at the user level. Okay, so to make a very, very simple example, if you have a process and this process should run the spell checker, but also, I don't know, run something else, for example, check if there are updates, software updates from the internet, you could write a function that checks for updates, a function that checks, that runs the spell checker, okay? But these functions could be written in a way so that periodically they get back to another function, and this function is the one that decides which one of the two to run. So you can emulate threads at the user level by writing code that makes sure that, let's say, half of the time you do something and half of the time you're doing something else. You can do all these things at the user level. On the other hand, you can do this at the kernel level. Okay, so letting the threads operate inside the kernel. And this is what you usually do with modern operating system and modern hardware. So there are different threading models. There is the many-to-one, one-to-one, and many-to-many. And I understand at this point, some of them might sound a bit strange, but hopefully during this lecture and during also the following one on scheduling, it will get a bit clearer why you want to do something like this. If you go to many-to-one threads, okay, what you do is that you define several threads at the user level, but you define a single thread at the kernel level. So from the operating system perspective and from the hardware perspective, you are running a process that is running in a single thread, okay? But at the user level, using a supporting library, you can periodically change, let's say, which function you run, which portion of code, so that you can achieve, for example, balance between the different functions. What is tricky here is that since the operating system believes that everything, sees everything as a single thread, as soon as one of your user threads requests something through a system call, the entire process will go into waiting mode. So in this case, it's useless to have many user level threads. If one of them tries to interact with the operating system through a system call or generates an interrupt, because all of them will be put into waiting, because for the operating system, everything is a single thread. The multi-threaded execution is being managed at the user level. The other alternative is to go one-to-one. For each user level thread, you define a kernel thread. Okay. In this case, if your thread that checks for updates from the internet requires interaction with the operating system through a system call because it needs to check something that needs to go through the network card, that thread can be put into waiting, but the other thread that runs the spell checker, it doesn't really need input-output with the hardware because it just needs to check what is in memory and whether what you're writing is correct or not, can keep running. Of course, this takes more resources for the operating system because you have to create separate threads and the operating system needs to be aware that these are different threads that belong to the same process. And as you might imagine, it's also less efficient because here you can have context switches between the different threads at the operating system level, okay? The more general one, or let's say the one in between, is the many-to-many model. So you could say, well, there are a certain number of user level threads, and these are mapped to a certain set of kernel level threads. Okay, and the mapping can be changing dynamically depending on basically the execution, what your code is trying to do, and so on.